Hi, my name is Stephen Hawes, the founder and CEO of Opulo, and this is the August 2025 Opulo company update. Opulo is an open hardware company making the Lumen PNP, which is a desktop pick-and-place machine used for automatically assembling electronic components onto circuit boards. The Lumen PNP is meant for assembling PCBs at a wide range of production scales, anywhere from just a handful of boards for a quick prototype run, all the way up to production of a few thousand units a year, like we do here, using the Lumen PNP to make boards in the Lumen PNP itself, literally building its own boards. As always, this video goes along with the blog post on our website, so if you're watching this on YouTube, there's a link in the description where you can follow along. As always, we will start with lead times. So we've been doing a lot of stuff here to try and get our lead times down. Like I've been saying in all these previous updates, publicly we have about a 4-week lead time on feeders and lumens, but internally we do ship quite a bit faster than that. We just really like to have the safety net of the longer lead time. We really just want to ensure we're going to ship things by the time we say we will. We spend a lot of time and money and infrastructure on getting it so that we can keep up with feeders. We've seen such an increase in our feeder demand, so we've been kind of re-architecting a little bit of how we use our space here at Opulo HQ to make more feeders. This also included hiring, so we hired more folks on, and like clockwork, as we get this bigger ability to do production, we've seen a huge spike in order volume over especially the past month. So I think we're just always going to be trying to expand our production capacity. We did get our internal lead time down to like a week and a half, maybe a little bit shorter than that at its absolute best. But with this huge spike, it's gotten back to around 2.5 weeks. We are actually still actively looking to hire even more people just to keep up with this increased demand. And now we have a little bit better infrastructure to support more folks actually working on building our hardware. So if you're in the Pittsburgh area and you're interested in applying, there's a link in the description. careers.opulo.io has all of our job postings, or if you know someone in the Pittsburgh area that would have a fun time building feeders, please drop us a note. We are actively looking for folks. And as always, the official lead time for every product is listed on each individual product page. This number is actually what we use to determine the deadline that we have internally to ship your products. So always reference that. That is always the most accurate way to know when something should be shipping. All right, next up is the paste utility. A couple weeks ago, I published a huge update to the web tool, the paste utility that we published to go alongside the paste extruder that we released in beta for the Lumen PNP. I've been working on this kind of in the background every once in a while, some on nights and weekends, just kind of for fun. And I finally got it over that last bit of development where it's ready for prime time. The utility got really 2 huge improvements that makes it so much easier to use the paste extruder now. The first is that you can actually import Gerbers. So in this web tool that you can go see right now, it's paste.opulo.io, you can import your Gerber files, your front mask layer and your front paste layer. And the tool is smart enough to look at the centroid of all of those different openings, decide which pads need paste, which ones don't and could actually be fiducials. You select the fiducials, and then here's the second big improvement. It has machine vision built in, connecting to the machine over USB to the controller for moving the machine, and then your second USB connection to the top camera. You can actually do fiducial calibration for your board. After setup, which only takes a couple minutes, you drop a board in even if it's not perfectly aligned, and the web tool will jog the machine, find the fiducial, do the linear matrix transformation to do the fiducial cal, line up all the pads, and automatically paste a board. This is a heck of a thing. It's all of OpenCV running in WebAssembly in a Chrome tab. It's kind of a wacky approach, but it does work exceptionally well, and I'm really happy with it so far. There's settings at the bottom so you can tweak your dispense parameters. You can also export a job and import it again later, including with where your board is mounted, so it's easy. You don't have to worry about keeping Chrome tab open. I posted a video on my channel a couple weeks ago about this new tool. There's a link in the description if you want to go check it out and see kind of how it works. If you have a paste extruder, please give this a try. I would love to hear about your experience with it. We have a paste extruder channel in the Lumen PNP Discord. Before this, you kind of had to manually capture each position, or you even had to use our Python library Leash for controlling the lumen and write a script yourself to do it. This makes it so much easier to just run a quick pasting job. And importantly, this tool still preserves the ability to just do maybe not a PCB pasting job, but you can just manually capture positions of where you want it to dispense a paste, and it'll just run that job for you as well. So if you're doing some other weird application, some other gluing, pasting thing that you're not really trying to put it onto a PCB, it's something else at different heights or whatever it is, you have that ability as well. I've tested it out pretty thoroughly for myself, but I want to hear about other people's experience with it. All right, next up is wide feeders. For all of our existing feeders, we have a flexure mechanism that pinches onto the film when it's getting peeled off, and the flexure allows the gears to split apart just a little bit and allow the film to slip once it's hit its limit. And this is a really convenient inexpensive, and reliable way to make sure that we only peel as much as we need to, and then it stops at that certain point. That does work great. But we were looking into the approach of potentially having some kind of sensor that can tell how much film has actually been peeled and once it's taut. This is something I've actually explored a long time ago in many different early prototypes of the feeder, and some chatter in Discord, some conversation that we were having made me want to look back into it again. This does change the mechanism about how the whole cadence of how film and tape is moved in a feeding process. It does change it quite a bit, and it's written very intentionally to make sure that certain things are deciding the actual position of where the tape's going to be, tuned for reliability and precision. So it's something that we definitely want to test a lot of before we make a lot of changes to the system. But I'm in the process of doing that now and experimenting with the different ways we can go about doing this and making it so that we have one extra input, one more sensor about the status of the system. This could also be coupled with having a spring mechanism holding the gears together, and this is nice because we could have the gears really interface tightly on the film. Right now we have just whatever the flexure gives us, but if we have a screw with a spring and it's adjustable, we can really clamp down tight as long as we know once we're taut, once we've hit that switch that shows, hey, the film is perfectly taut and we know when to stop, then really being able to tighten down the gears that pinch the film works a lot better. So I'm deep in the process of doing a lot of this kind of iteration and exploring the different ways we go about doing this right now. Wider tape also has a stronger adhesive between the film and the tape, so making sure we really make sure that the film peeling is working well on these wide feeders is critically important to their success. Lots of testing and exploration going on with this right now. Okay, next up is board mounting hardware. We've added a new product to the web store. This is a small but pretty useful thing that we noticed. A lot of people were buying our Getting Started kit, which is a product that has the FTP, the test board that you use for calibrating your machine and testing your accuracy, and a few other miscellaneous things, some components, and some parts that are used to mount a PCB to your staging plate. A lot of people were buying extra Getting Started kits just because they needed more hardware for mounting their PCBs to their staging plate, and they were getting a bunch of other stuff that they didn't need. We just broke them out and we made it a whole separate product. So if you just want more hardware for mounting your PCBs to your staging plate, we now have that as a separate SKU. You can go and buy that. There's a link in the description if you just want to pick those up, and you don't need all the extra stuff that comes in the Getting Started kit. Thank you to the folks that reached out to us about this and told us that this is something that you wanted. It was incredibly helpful. All right, next up is a new project. I've been running a lot of experiments with making PCBs at home or in the office for rapid prototyping, especially with the paste extruder on a Lumen. It's such a killer way to make very, very fast iterative PCBs. The problem is it's very hard to make vias. Rivets are kind of inconsistent and don't scale very well. They're kind of annoying, and electroplating is messy and time consuming and can get expensive. What if the vias were already in the board? I designed a PCB that has a standard array of vias and 0 traces. When you want to quickly design a PCB for testing, you design around this pre-made template of a PCB with all these vias already laid out for you. Then you toss it into the laser, etch your front side, etch your back side, and you have a finished 2-sided PCB. The vias are already in the board from the beginning, you're just deciding what they're being used for. I imagine this being a type of standard, kind of like a solderless breadboard, where you just design all your first pass of a PCB around this standard PCB design, where the vias are, and you route to these existing vias, and you have a bunch of these already in stock. You drop one of these boards into your laser, etch both sides, and it's a standard format for quickly testing SMT designs. And from there, you can drop it into the Lumen, solder paste dispense it, place your parts, and you have a prototype in like an hour or two with double-sided boards and vias. Designing this via layout, I think, is the trickiest thing here. If your via density is too high, you have a really hard time dropping larger components in or weird footprints without laying on top of a via. If it's too sparse, then you also don't have enough connections to actually make your PCB. On a recent really long flight that I was on, I took my beginner template for what this grid could look like, and I tried to design a bunch of boards on it. And I made a couple adjustments and tweaks and changed some density and stuff, and I have something that I think will probably work pretty well. I have some prototypes of these boards coming in the mail right now, along with a new different type of laser someone at OpenSauce told me about, which is actually capable of pretty easily etching FR4 based PCBs instead of the fiber laser that I've been using for the FR1. And if this works out well, I think this is gonna be so huge for quick iteration of actual PCBs with 2 sides and real vias. Fast ability to test out a new design, iterate really, really quickly within the span of an hour. So very excited about that. I will probably be making some videos about this in the future, coming up pretty soon. All right, next up is Hardware Cafe. I recently posted a video on my channel about taking the Lumen PNP through its most recent pass of certifications for V4. And alongside this, I also put up a small website that's gonna try and codify some of this information about running a hardware company and resources that are useful, really tricky lessons learned that maybe some of us have spent a lot of money doing the wrong thing and would like to save other people the trouble. It's at hardware.cafe, and right now it's pretty sparse, but I want this to be a place where a lot of people in the community can add information and make it a repository for other people that are trying to ship hardware. So if you have some hard lessons learned and you're shipping hardware right now, I would love to see a PR. There's a link to the repository in the description. All right, and that's it for this month. Thank you so much for watching. If you have any feedback, questions, comments about what I said in this video or the format of doing this, please do not hesitate to leave a comment. I would love to hear it. Or you can reach out to us at support.opulo.io. Thank you so much, and we'll see you next month.